So now we're going to use our ratios to work on solving for a missing side. Before we move on, please make sure that your calculator is in degree mode. I've put a little screenshot and some instructions on the top of page 10, which is where we're starting. So if we want to solve for a side given an angle and a side, so before we could use the Pythagorean theorem when we had two sides. But if you're just given one side, you can still figure out a side of a triangle if you're also given an angle. So here I'm given angle A is 42 degrees. So if I wanted to go through and label this, right, this is my adjacent, this is my opposite, and this is my hypotenuse. So in this case, have my adjacent and my hypotenuse labeled. Even though my adjacent is an x value, that is still something we're solving for, and it's something that is labeled. So I have the adjacent and the hypotenuse, which tells me that I can use cosine. So what I know is that the cosine of my angle A, which is 42, must be equal to my adjacent x over my hypotenuse 9.5. Now you can solve this because if you look, you can actually just imagine that cosine of 42 degrees is over 1 because anything can be written as a fraction over 1. Now you cross multiply. X is equal to, and now in your calculator, you're going to use cosine 42 times 9.5. And you should get that x is equal to 7.0598 ... which I will round to the nearest tenth, which is 7.0. So this is how we can use the ratios to solve for sides. So first, again, you're labeling. Determine what function you would use based off of your labeling. Set up your proportion, cross multiply, and solve. So if we want to solve for the missing side, so I'm given this angle, opposite it is x, adjacent is 17, hypotenuse we do not have. So if I have opposite and adjacent, I know that I'm going to use tangent. So if I'm using tangent, so I'm going to say that tan of 38 is equal to opposite is x, adjacent is 17.